Hey everyone, welcome to video 8-3A. We're going to split this lesson talking about the medians and altitudes of triangles into two videos. So with our first definition here of median, median as a vocabulary that you need to know is a segment whose endpoints are first a vertex, so in this picture the vertex is B, and then the midpoint of the side that is opposite that vertex. So the side opposite that vertex is AC, and so B joins, the median joins B, and then the midpoint of AC, and that's what median means. So we have several medians, obviously, in a polygon, and in a triangle we have three medians because we have three sides. So we're going to explore in this video what happens when those medians come together in one point. And I'm skipping ahead here to page 383, where we're talking about the Centroid Theorem. Now, the Centroid Theorem says that the centroid, or the intersection of the three medians of a triangle, is located at 2/3 of the distance from each vertex to the midpoint of the opposite side. Now, so what you can see here in the definition is that if I wanted to talk about P being the centroid, this point right here in the middle, then AP is 2/3 the distance of the full median AX. Same from point B. BP is 2/3 the distance for the entire median length BY. And CP is 2/3 the distance for the entire median length CZ. Now, you guys, I like to think about this in a little bit of a different way. So I'm going to give you guys some additional notes that I think might help. Another way to think about it is that the longer segment of the median itself, because as you can see in the picture, there's always a short segment and then a longer segment. A short segment, a longer segment. You can see that with the centroid. Another way to think about it is that the longer segment is always equal to 2 times the shorter segment. Because if it divides it into 2/3 of the entire distance, then we could also say kind of that it was partitioned into a ratio of 2 to 1. So that's what we're thinking of here. So in other words, if I have this same exact diagram, AP is twice the length of PX. And BP is twice the length of PY. CP is twice the length of PZ. Okay? So if I know the entire median's length, then the median itself is equal to the long part plus the short part. And if the long is twice the short, and we don't know either one of those pieces, we could say the short is x and the long is twice that length. So we could kind of make an equation and say that the median is equal to 3x, where again x is the shorter length and 2x is the longer length. Okay, so that's going to come in handy a little later on. In example 1, though, it says use the centroid theorem to find the length. We need to find, if we know AF is 9 and CE is 7.2, then we need to find AG, which is this longer length of the median here, and we need to find from that, using the centroid theorem, if we know the whole length of AF is 9, then we need 2/3 of 9, basically. And so we get that AG has the length of 6. On the next page, if we're using the same diagram and we're finding GE, just to keep track here as you're looking back at the diagram, you may need to flip back and forth here a little bit, but GE, as a reminder, is one of the short pieces of the median, and so GE would be take the long part, which is 2/3, subtracted from the whole length. So we're told that, just to do a quick resketch here, this is point E, this is point C, and then our centroid G is right there. So CG is 2/3 the length of CE, and we were told that CE was 7.2. So CG is 4.8. So that's this part right here, 4.8. And then remember, we wanted to find GE, which is the shorter part. So that's CG plus GE. And if we subtract CG from CE, or 7.2 minus the 4.8 we just found, we get that GE was 2.4. Using the idea that we talked about on the previous page, though, if you took the entire median's length and set it equal to 3x, the median length of CE set equal to 3x of 7.2 there gives us that x comes out to be 2.4, which is the same number that we got after we had to do a 2/3 and then a subtraction. So it may help you guys to think about that alternate way in a situation like this. Okay? So a quick little reflect here, number 3, it says to find the centroid of a triangle, how many medians of the triangle must you construct? And just so that you know, we actually only need to actually put 2 of the medians together because it takes 2 lines to determine a point of intersection. Now it is true that the third line will go through that same point of concurrency, but we really only need 2. So now that you have a little bit more of the centroid theorem under your belt here, let's go down to the your turns, and please take note of what I wrote on your outline, you guys, for problem 6, 7, and 8 for your turns. You want to make sure that you take the verbal descriptions that they're giving you and make a very careful sketch and label them very carefully here as you're working through these problems. So take a pause in the video and work through these 3 problems before you go on to the last part. Okay, moving on to page 385 and explain 2. We're going to be finding the intersection of the medians of a triangle when it's on the coordinate plane. So you can see the points that you're given here, Q, R, and P, and what the problem is asking you to find is the centroid and what information does the graph provide that's going to help you find the answer. It gives you the coordinates of the vertices, and so the centroid is the intersection of the medians of the triangle. So we're going to begin this whole entire process by calculating the midpoint of one side of the triangle, and then we're going to draw a line to connect that point to a vertex. We only need to draw 2 medians to find the centroid. So let's walk through the solution here. It says first let M be the midpoint of QR, and so they're going through the midpoint theorem here where you're taking the average of your x coordinates. So x's coordinate for Q is 0, x coordinate for R is 6, so 0 plus 6 over 2. Y coordinate for Q is 8, y coordinate for R is 4, so 8 plus 4 over 2. Therefore the midpoint as we calculate it out, comes to be 3, 6. So let's plot the point 3, 6, and I'm going to zoom in a little bit on this diagram so that we can do that nicely. And so 3, 6 is here, and that is the midpoint M. And if we want to connect that across the triangle to the point opposite it, that is going to be this line right here. So MP is one of our medians. Then we'll go back to calculate the midpoint of our other side. N is the midpoint of QP. So again, QP is this side on the left-hand side here. So we want to do the average of the x's, 0 and 3, and the average of the y's, 8 and 0. And for that one, we get that N is the point 1.54. And so we'll go put that on the diagram, 1.54. Zoom in a little bit. And 1.54 is right here. And that's point N. This was M, remember? And then we want to connect that point to the vertex that is opposite it. So that's going to be a nice horizontal line right here as well. Okay, zooming back out. Now that we have those medians, we want to find their equations. So we're going to draw a segment. Oops, we already kind of did this on the diagram, but let's fill in the words anyway. Draw a segment to connect M and point P. And that equation is the vertical line. So it's got to be an x equals, remember. And what does x equal on that line? X equals 3. Then we're going to draw a segment to connect N to the vertex opposite it, which is R. And that is a horizontal segment. And horizontal segments have y equals lines for their equations. So that is going to be y equals, and on that entire line, y equals 4 for the coordinates. So the intersection of those two medians is the point 3, 4. And so go ahead and put that point right in the middle there, and that is my centroid C. On the next page, page 386, we're going to talk about how to justify whether 3, 4 is truly the centroid. And the answer seems reasonable because it seems to be positioned in the middle of the triangle, but we know some things about the centroid that we want to apply here. So to check it, we're going to find the midpoint of the other side that we haven't used yet, RP. And the midpoint of RP, where you have 3 plus 6 all over 2 and 0 plus 4 all over 2. And we'll call that point L. That's going to be 4.52. And we're going to draw that third median there, 4.52. So we have QL is the third median, and the slope of that third median, if we were to do the slope between 0, 8 and L, which we just found as 4.52, you can see the calculation there. We do 2 minus 8, there's my numerator, over 4.5 minus 0, the x-coordinates, and so that comes out to be negative 4/3. The equation that describes this red segment line right here, QL, is going to be the negative 4/3 slope plus the y-intercept, which also actually happens to be point Q, or 8, for the y-coordinate. And so it intersects the other two medians, as we know, at point 3, 4. which confirms C as the centroid. Okay, so we can go ahead and see that truly it does intersect there. If we were to take the original equation that we just had for QL, negative 4/3 x plus 8, and we were trying to figure out what its coordinate would be if x was 3, and we substituted that in for our 3, negative 4/3 for our x, 3 goes in for our x. And we're trying to figure out what would the y coordinate be if x was 3, and hopefully it's going to come out to be 4. Let's see. So that would be y equals, my 3's are going to cancel out, negative 4 plus 8, or 4. That confirms that the point 3,4 is indeed on that third median line. The other thing that we can do is we can apply the centroid theorem to check your answer. So if we talk about this median that we know is coming across here from point N, which is 1.54, remember, to the vertex opposite it, and then through the point C right there, which is 3,4. We know that the centroid theorem says that RC, which is this long distance of the centroid, is supposed to be 2/3 of the entire length of RN. Remember, N is that midpoint there of that side. So what is the length of Rn if we just simply count the distances on my coordinate plane? I hope you can see from R to N is 1, 2, 3, 4.5 as a distance. And RC is simply 1, 2, 3 to get to the point 3,4. So if we substitute those values into this top equation right here, we want to know, does it come out to be 2/3 of the distance with the centroid theorem? So RC is 3, 2/3 of 4.5 is in fact 3, and so it comes out to be true. So with your turn here, number 9, that you have assigned, you want to go ahead and plot the points and find the centroid. I really highly recommend that you use graph paper of some kind. And you can see the instructions here have been given to you on your outline. So make sure that you follow the instructions as far as your labeling of the midpoints and of which segment you want to use to check the equation and to check the partitions of the medians. Okay? So we'll see you guys in the next video.